Hey everyone, welcome to the first video in our Tekla Extil training series. I'm Ali Olgun and I'll be your guide through these tutorials. I've been working as a structural designer in an engineering firm for 15 years. With my extensive experience using Tekla Extil, I aim to share my knowledge with aspiring designers, draftsmen, and civil engineers who want to learn this powerful software. The first two videos will cover the program's basic principles and design logic. Understanding these fundamentals will help you grasp the why behind our actions in later tutorials, allowing you to build a solid foundation and truly master the program's core concepts. When we start and look back, we'll have fewer questions. At least we'll know where we stand, unlike other tutorials where we jump right in. That's why I didn't want to start with the training videos immediately. We need to understand the program's logic, how it works, and what we do with it first. Once we begin the tutorials, we'll be more at ease. By having this background information, the questions in our minds will disappear. First, let me briefly explain what Tekla Extil is. Tekla Extil is mainly used for designing, manufacturing, and planning the assembly of steel structures. It's a 3D modeling and design program that helps manage the entire process from start to finish. It can also be used for concrete structures and quantity takeoffs, but we primarily focus on steel. We'll mainly focus on steel in our program. Our training series will cover steel, steel design, and the fabrication process. Now, I'll explain the basic working logic of XT. The main components are the model screen, design outputs, manufacturing, and assembly phases. Let's look at what we do in Tekla XT. First, let's see what we're dealing with. When we open it, we see this screen. This is our design area where we do all our work, friends. In the model design screen, we create our X-style parts, columns, and beams. This is the first stage of the program. When we start, we need to model correctly. In X-style, we need to accurately build the given construction right here. All right, friends, in the second phase, after our model is completely finished, we'll model the 3D design in detail. Then we'll see the manufacturing output screen. The model's done, but just visualizing it isn't enough. We need to present this 3D model to the steel workshop for manufacturing. This is the program's second phase, which we'll use. It's under the driving and report menu called the driving list. When we output our finished design, this menu will appear. We'll manage all drawings and production here. So, first phase is 3D design completion checks, numbering, and then next is reviewing the outputs under the driving menu. The manufacturing phase comes after. We've finished the first phase, completed the design, got the manufacturing outputs. Now we need to organize these outputs. Raw data won't be useful because the drawings can be hard to read and the program isn't perfect. We fix these issues. This is the manufacturing phase, which you'll find under this menu, folks. The next stage is assembly. After manufacturing is done, we finish up in the workshop, complete the welding, and wrap up all processes. Then we ship everything to the site. Those elements need to be joined together. They do this using the general layouts we prepare here, like the one you see. We create these too. So, what did we cover? The model designer screen is where we create our model. Then, from the finished model, we produce design and manufacturing outputs. We prepare the outputs, then refine our manufacturing drawings. Next, we create general plans to guide assembly when parts move from workshop to site. All right, folks, let's talk about the model design screen in Tekla. The program asks us for a few things. So let me explain. What are these three stages? These three stages in the program's design logic: parts, assembly drawings, and general assembly drawings. Friends, in our program, every element we add, whether it's for a small or large project, is a separate part in the program's logic. Each of these is a distinct component. Until you connect them to another element, let's demonstrate it this way. Let's weld this and create a connection. I've welded it to our column. Now this is a part, but if I weld it to the element I placed here, you see, it becomes the main element. These two form an assembly. In our program, the foundation of all our drawings is based on parts and assemblies. Parts create assemblies, and assemblies combine to form the final assembly drawings and general layouts. Now, based on this, let me show you an example. I'm opening it up. Friends, looking at this porch project, each element here is a separate part. This is a separate part, this is another, and this is yet another. We call each of these a part, derived from part. As you see under drawing, when we select Create Single Part, we make separate drawings for each component in the model. But if I weld this column to this, when I weld this plate to the column, it becomes an assembly. These form an assembly. Think of it like this. This pen in my hand, if you think of it as an assembly, consists of assembled parts. If you consider it an assembly made of combined parts, let's look at what it's made of. There's a handle, a cover on the back, and an eraser inside. It has a separate tip at the front with a nib inside. It's made of many parts. This is an assembly. Let's call it K. It might consist of about 10 separate parts. This is the concept of assembly and parts. We need to understand this first, folks. In drawings, after design and manufacturing plans are done, we'll prepare the following: part cutting drawings, individual sketches of each separate component you see here, and assembly drawings showing how parts fit together. How many parts make up this column? Well, to put it very roughly, it consists of 2 steel profiles and maybe 20 plates like this. At the top, we have a separate header plate, and at the bottom, we have a base plate. It's made up of these components. This forms a column assembly, friends. This was the second stage. First, we mentioned part cutting drawings. We'll get separate drawings of all parts in the system. The program does this automatically, which is its best feature. 2, assembly drawings of parts, showing how pieces fit together. 3, general assembly drawings of the entire system. These are the basic drawings, friends. This is the fundamental logic of our program. Now let's look at an example. Here are the single parts of the column. We're looking at the PA9 part. This is one part, as you can see. Now let's give an example of an assembly. This is part of the BC column, an assembly of the column, which is itself a part of the column. All right, folks, as you can see, we're describing the assembled version and how to build it in the workshop. Here's how many parts make up this column. Our column is called BC8, and it consists of these parts: PC3, BC7, PC10, PC12, and PC. That's the general overview. To sum it up, friends, our program's logic involves part cuts, single part drawings, as you can see, assembly drawings, and general layout plans. These 3 elements form the core of our program's functionality. If you can grasp this concept, you'll understand the program's logic, and based on this, in our other videos, you'll better comprehend where we are and what we're trying to achieve. Our second video will cover basic construction design logic, how we place these parts and assemblies and why. Thanks for watching, and we'll see you in the next video. Take care.